Hello. In this video we will be discussing a concept called chirality. Turns out that some molecules, like some actual objects in the world, have a property called chirality. They are said to be chiral. Basically, chiral means handed. So some objects you can have a left-handed version and a right-handed version, which are not the same as each other. Other objects are achiral. So let's define what we mean by chirality. So there's two criteria here, but they are the same as each other, as it turns out mathematically. But it's useful to have two different ways of thinking about it. So first of all, an object is chiral if it has no plane of symmetry. So what do we mean by a plane of symmetry? We mean a plane that can cut the object right in half, in which this half is the mirror image of this half. In other words, if you cut it in half, the two halves can look across a mirror and see the other half directly. That's a plane of symmetry. If an object does not have a plane of symmetry, then that object is chiral. Good example is your hand. By the way, chiral means handed, so your hands are kind of the ultimate example of a chiral object. So think about your hand. Does it have a plane of symmetry in it anywhere? And the answer is no. No matter how you hold it, no matter what shape you put it in, no matter how you orient it, it does not have a plane of symmetry. And you might say, yeah, but isn't this a plane of symmetry right down through here, so that your palm is on one side and the back of your hand is on the other side? And the answer is no, that's not a plane of symmetry, because if it were, you'd have to have a palm on this side and a palm on this side, but this does not have a palm. Therefore, this is a chiral object. Interestingly enough, you have the opposite mirror image of it right here, and that brings up the second criterion for chirality. It is chiral if it is not the same. Other words we use are identical or superimposable, but basically means is not the same as its mirror image. So here's one object. Here's its mirror image. Does everybody agree those are mirror images of each other? In other words, if this one looks in the mirror, it sees this one. So these are mirror images of each other. Now, everything has a mirror image. That's not the question. The question is it the same as its mirror image or not? So is this object the same as this object? And the answer is no. No matter how you turn them, you can turn them this way, but then your thumb and your little finger are trying to be the same as each other, which they're not. Or you can turn them this way, but then your palm on one side is trying to be the same as the back of the hand on the other one. So these are not superimposable, in other words, not identical, not the same as each other, and therefore they are chiral. So there's two criteria: no plane of symmetry and or not the same as its mirror image. And as noted here, those criteria are the same as each other. They're just different ways of stating the same thing. Now here are some objects. Take a minute and see if you can use what I just told you to determine if they are chiral or not. Some of these objects are and some of them are not. So if you want to pause the video for just a minute and see what you think. Okay, so let's just go through these one at a time. What about this chair? Is that chiral or not? Well, hopefully you recognize that there is a plane of symmetry in the chair. It cuts right down through the back of the chair, right down through the seat of the chair, and cuts all of these different bars right in half, so that this half of the chair is the mirror image of this half of the chair. In other words, this has a plane of symmetry, therefore this is not chiral. In other words, we call it achiral, so this is an achiral object. What about the shoe? Well, clearly it does not have a plane of symmetry. You can't cut it through here because then the toe would be trying to reflect into the heel. You cannot cut it right down through the center like this, because the part where the big toe fits would not reflect into the part where the little toe fits, and so on. In this case, it might be easier to think about it in terms of its mirror image. Does it have a mirror image? Well, of course, every object has a mirror image, but what is the mirror image of this? Well, it would be the other shoe. So if this is a shoe that fits on the right foot, then the shoe that fits on the left foot would be the mirror image of it, and it's not the same as the mirror image, as evidenced by the fact that you can only put one shoe on your right foot, but not the other. So they're not the same as each other. They are mirror images, so this, in fact, is a chiral object. Of course, its mirror image would also be a chiral object. You can't have a chiral object without its mirror image also being chiral. That's just a hard and fast rule. So this is chiral. It is handed. In other words, this actually is you can label this as a right-handed, or in this case, the right-footed shoe, if you will. What about this coffee mug? Is it chiral or not? The answer is no, because it does have a plane of symmetry. It cuts right down through here, cuts the handle right in half, and cuts the bottom right in half. The one part of it would be the mirror image of the other part of it. So this is achiral because it does have a plane of symmetry. Now I don't have a picture here, but you can imagine what the mirror image of this would look like. In fact, the mirror image would be exactly the same, and so therefore it is the same as its mirror image, so therefore it is not chiral. This is like the chair is an achiral object. How about this desk? Well, this one clearly is chiral because it does not have that plane of symmetry. Now, if this desk part here weren't there, then it would be just like this chair. It would be achiral, but because that is there on one half of the object, but on the other half, that makes it so that there is no plane of symmetry here. Therefore, this is a chiral object. In this particular case, this is a right-handed person's writing desk, but there are left-handed writing desks that a left-handed person could use. It would be the mirror image of this, and again, they are both chiral because they are mirror images, but not the same as each other. How about a golf club? Well, clearly this is chiral also. It does not have a plane of symmetry anywhere. You might say, well, doesn't it cut right down through here and right down through the shaft? And the answer is no, because the face on one side would have to have a face on the other side exactly the same, and it does not. So therefore, this is probably a right-handed golf club. So somebody who is right-handed could use this one. If you are left-handed and if you're a golfer, you know you have to have special golf clubs because right-handed people can't use left-handed golf clubs and vice versa. That's just to say that they're not the same as each other, therefore they are chiral. So a golf club would be chiral, except possibly a putter. And you might think about, in some cases, a putter might actually be achiral. How about a hammer? Well, that is achiral because it does have a plane of symmetry. Cuts right through here, and down through the shaft, splitting it one half on one side, the other half on the other side. Those two halves are mirror images of each other, so therefore this does have a plane of symmetry. It is not chiral, and you probably know or could guess that there's no such thing as a right-handed hammer and a left-handed hammer. Right-handers and left-handers can use them equally well. That's because they're not chiral. Now, let's think about these two objects, a screw and a spiral staircase. Is this chiral or not? And the answer is yes. One thing you can just always keep in mind, a spiral is always chiral. I think they rhyme with each other just by coincidence, but it's a useful thing. Anything that has a spiral in it is automatically chiral. Now you might say, well, can't we split it right down through here, and this half would be the same as this half? Nope. If you split it right down through here, then this bump coming out here would have to have a bump at the same place coming out here, which it does not. And this bump over here would have to have a bump over here at the same place, which it does not. So this does not have a plane of symmetry. Okay, well, what about cutting it right here? Isn't that a mirror plane? And the answer is no, because this bump up here would have to have a bump down here that was at the same place, and it does not, and so on. So basically, and the same thing could be said here. Now, maybe not so obvious in the case of a spiral staircase, but in the case of a screw, you know that it is handed, because if you turn it one way, it goes out of the piece of wood. If you turn it the other way, it goes into the piece of wood. In other words, relates differently for screwing it to the right as it does for screwing it to the left. So therefore, it must be chiral. Now, is it possible that there are two different kinds of screws, left-handed screws and right-handed screws? And the answer is it's possible, but they don't exist. It's turned out that over the years, everybody who cares about screws has decided that we will all use the same kind of screw. And so all screws, you recognize the term righty-tighty, lefty-loosey, all screws, if you turn them using proper screwdriver, turn them to clockwise, that is to the right, they will go in. And if you turn them counterclockwise to the left, they will come out. You could just as easily have it be the other way, but everybody has decided that it should be righty-tighty, lefty-loosey, and therefore everybody uses the same kind of screw, and there are no mirror images, objects that we could look at. You could manufacture one, but turns out they're not manufactured. Turns out light bulbs are the same thing. You have a little screw in the light bulb, screw it in. They're all the same way, so that if you turn it to the right, it goes in. If you turn it to the left, it comes back out again. Again, there's no reason they have to be that way. It's just everybody has agreed that that's the way they should be. And you could imagine a mirror image of a light bulb, which would not fit into a socket because the socket is designed to have the normal type of light bulb screw into it. Again, anything with a spiral is automatically chiral. Now I have some other objects here. How about this bookend? Hold it up here and let's take a look at it pretty carefully. Is this chiral or not? And the answer is it is not chiral because it does have a plane of symmetry right down through here, right through the middle and right through the metal. And so this half of it directly reflects into this half of it. So that corner reflects into that corner, and that little pattern reflects into that little pattern, and that little pattern reflects into that little pattern, and so on. So this is achiral. In other words, not chiral. You have to remember, achiral means not chiral because it does have a plane of symmetry. If I had a mirror image of it, I could put it right here next to it, and you would see that it is in fact identical. You could superimpose them on each other, and it would fit in every way. So this is achiral. How about this little wooden statue? Think that's chiral or not? And the answer is chiral, because it does not have a plane of symmetry. This bull has its head tipped to one direction, so if it was right in the middle, it would be chiral, but it's not. It's looking in one direction, so therefore this is not a plane of symmetry right down through here. In fact, there is no plane of symmetry, no matter how you might try to cut it. There's no plane of symmetry here, so this is chiral. I don't happen to have a mirror image of it to show you, but if you held it up to a mirror and looked at the mirror image, you would see that they're not the same as each other. You couldn't move them together and make them superimpose. So this is chiral. How about this mask? Chiral or not? And the answer is not chiral, because it does have a plane of symmetry right down through here. This part reflects into this part, this eye reflects into that eye, this piece of sparkle here reflects into a piece of sparkle over there, and so on. So this has a plane of symmetry, so therefore it is achiral, not chiral. And let's take a look at a pair of scissors. Is this chiral or not? And you might say, well, this is not a plane of symmetry right down through here, because this side is a little bit bigger than that side. How about, though, right down through here? Is there a plane of symmetry that cuts the pair of scissors right in the plane that they are occupying? And the answer is because if you open it up, you'll see that one blade is on this side of the plane and the other blade is on this side of the plane, and therefore it's not the same on both faces of that plane of symmetry, and so therefore it does not have a plane of symmetry, so therefore it is chiral. And those of you who are left-handed know that a right-handed pair of scissors, which is what this is, very difficult for a left-handed person to use. In fact, they make left-handed scissors for left-handed people, and the left-handed scissors would be the mirror image of the right-handed scissors. Not the same thing as each other, so therefore chiral. And lastly, let's look at a molecule. This is just a made-up molecule. I put a white ball, a red ball, a yellow ball, and a blue ball. And this will represent any molecule that has 4 different groups on the same carbon. So this is carbon in the middle, yellow, red, white, and blue. Is this chiral or not? And the answer is this is chiral, because it does not have a plane of symmetry. No matter where you try to cut it, you're going to be looking at a different colored ball trying to reflect into a different colored ball. No plane of symmetry here, so therefore this is chiral. So looking at the second criterion then, is this the same as its mirror image? Well, I have a mirror image here. Let's just look at these this way, and I think you would all agree that those are mirror images of each other. So the red ball sees the red ball in the mirror, the yellow ball sees the yellow ball in the mirror, white ball pointing away from you reflects into the white ball in the other molecule, and so on. So these are mirror images. The question is, though, not whether they're mirror images or not. The question is, are they the same as each other? And the answer is, no, they're not. No matter how we turn it, if we try to make the red ball and the yellow ball coalesce with each other, then you'll notice down here the white ball and the blue ball. Blue ball is trying to coalesce with white ball, and back here, same thing. So let's make the white ball and the blue ball coalesce, but then the red and the yellows aren't lined up properly. So no matter how you turn them, no matter how you make them fit, they will never superimpose on each other. Therefore, they're not the same as each other. So anytime you have mirror images that are not the same as each other, each one of them is chiral. So this is a chiral object, and this is a chiral object. That gets us into the next video, which is going to talk about molecules and whether or not they are chiral, and the existence of these 2 different forms, even though they're very, very similar, they're mirror images, but not the same as each other. And that's it. So thank you for your attention.